Hello friends, welcome to the CEC live lectures. Dear friends, today in this session we are going to talk in our series on cloud computing. Today we are going to talk specifically on loading balance and in cloud computing. Friends, for the discussion on the topic, we have with us in our studios Dr. Mansaf Alam. Dr. Mansaf Alam is Associate Professor and is Associate Professor in Department of Computer Science, Jamia Millia Islamia. Dr. Mansaf Alam has immense experience and through the dint of his knowledge and wisdom, he always gives us in-depth knowledge on various topics of computer sciences. Friends, if you wish to ask questions from Dr. Mansaf Alam on today's topic, then do call us through our toll-free number. Our toll-free number is 1-800-110-430. I repeat, our number is 1-800-110-430. You are just requested to call in the last 10 minutes of the lecture, as well as we request you to ask questions relevant to the topic only, that is cloud computing, and specifically, as I told you, we are talking on load balancing in cloud computing. So I would like to welcome our guest, Dr. Mansaf Alam, once again. Hello sir, welcome to the lecture.
Hello friend, today I'll discuss about the load balancing, and in load balancing how load are balanced in the cloud computing. A server having the heavy traffic and using the load balancing techniques, load balancing device, we can help to balance the load. In this topic, I'll also discuss why load balancing is required, what are the advantages of load balancing, what are the various types of load balancing algorithms. So all details we'll see in details, but let us start from the load balancing. So here, what is exactly load balancing? So load balancing is a process to distribute the workload among the server. So you can see here in a definition, load balancing is the process of distributing workload and computing resources in cloud environment. Let us see here, there are 7 server and 100 clients, and all 100 clients are wanted to interact with the server. So if you have a 7 server, so load will be heavy, and one server having the 10 client, another having the 20 client, and next one having the 40 client requesting the server. So 40 client requesting the particular server, that having the heavy load, and also the first server only 5 client are interacting, that is the lightly loaded server. So how to balance the load among the server, or you can say the node? A concept of load balancing is used to distribute the task among the server equally, so it can't be biased with any other server, and in this way you can increase the performance of the server. Now let us see here exactly the load balancing that allow companies or organizations to manage the applications or workload demand by allocating resources among the various computer, network or server. So load balancing in cloud computing that include hosting, the distribution of workload, traffic and demand over the network. So first on the first level, that all clients are organized, and the second level, that all servers are organized, and in between these two, a load balancer are used to balance the load among the server, and that is generally used by the company or organizations to manage their applications. Now a question is here, why the load balancing is needed, and is it not possible in the existing system? So first we will see it, how the existing system work before it, and what is the benefit after using the load balancing in cloud computing. So this diagram gives details about client interaction with server without using load balancing. So let us see in this diagram, there are three client 1, client 2 and client 3, and we have three server 1, server 2, server 3, and that's all server identified with the help of IP address. The first server IP address is 10.2.0.1, second server IP address 10.2.0.2, and third server IP address 10.2.03. So these three servers are here, and that client can interact with the particular IP address. So suppose a client 1 want to interact with the first server having the IP address 10.2.0.1. So first client request to DNS domain name system, and there is a list of all the IP address that associated with the server is listed there. See on the top of the DNS, 10.2.0.1 that interact with the first server, 10.2.0.2 that interact with the second server, 10.2.0.3 that interact with the 10.2.03. So first any client want to interact or send the request to a particular server, so first send it request to the DNS, and through DNS it will be connected with the particular server. So client 1 will be connected with the 10.2.0.1. Similarly, next client 2 want to interact with the server, so it will send to the 10.2.0 that is connected, and third one client want to connect with the server, that is the third server 10.2.0.3, then it will be connected. But what is the problem with the such type of a system? Sometimes your systems fail during the execution. Suppose let us see here, the client third 10.2.03 is failed, and some client was interested to interact with it, so it will continuously sending the request to the server 10.2.0.3, and request will be sent regularly, but there is no response because DNS is not aware about the server third, whether server third is working or not, but the exactly server third is not working. Even then DNS did not get information that server 3 is not working, and client continuously requesting the particular server, so it will not get the response. That is the main problem. So this diagram show the problems that arises without using load balancers. The DNS is not aware whether a particular server is working or not, and continuously sending or sent request to not working server. So this is the problem with the existing system without using the load balancing. So you can use the load balancing techniques to solve such type of problems. The main problems, you can understand that the server is not working, even then client are requesting, because DNS does not have the information about the particular server that is not working, and regularly sending the request to the particular server which is not working. This is the main problem. To solve this type of problems, we have to introduce the load balancing technique. So load balancing technique that is used to distribute the load among the various servers, so that you can reduce the traffic and increase the performance. So client can get the response easily, the client job will be processed immediately, and if any system or server is fail, then a client will be aware about that failure. So let us see here how the concept of load balancing is incorporated in the existing system. So the problem faced with DNS is resolved by introducing load balancer in this diagram. So this is the diagram with the load balancer. So you can replace DNS with the virtual server with IP address 20.2.0.1, that is the virtual internet protocol VIP, that is the IP address. and these cloud are connected with the virtual server along with the load balancer. In this diagram, let us see, this is the virtual server and this is the load balancer. This is your cloud and this is the client. So client 1, client 2, client 3. So client 1 want to interact with a particular server, so it will give the request to the virtual server and it will directly connect it to the virtual server, that is this is the physical server, that is the 10.2.0.1, 10.2.0.2, 10.2.0.3. These three all are the physical server, and between the physical server and the cloud you have to use the virtual server and then use the load balancer here. So this is the connections and diagram of using the load balancer in the existing network to take the request from client to the server. So how this work? So see, there is a, this is your node, this is a server, or you can say this is the node 1, node 2 and node 3. Now you have to use the services. Let us see what is the services. So services is http xyz.com TCP port 80. So node 1, the services will be node 1 10.2.0.1 and node 2, and that is the 10.2.0.2 and node 3 10.2.0.3. Then services member. So service member is 10.2.0.1:80 is the first service, 10.2.0.280 is the second service, and so on 10.2.0.3:80. So these three are the services and three are the node. So these services, all services along with the node combined all together, that is known as the pool service member or a pool server. So in this way you can use the load balancer in your cloud computing system to balance the load or distribute the workload to the particular server. Now let us see exactly what is load balancers. So load balancers allocate the workload and balances it between two or more cloud servers. We can so outline our infrastructure to permit it to meet activity spikes, optimize the allocation of resources, and guarantee a minimal response time using a load balancer is recommended in all cases, whether we require one or more of the following. So first, guarantee service continuity. So it is responsibility to provide the guarantee of the services, that is the continuity. So services will be continuous, that will be guarantee given by the load balancer. And the second one, that is to handle the high traffic. If there is a high traffic, that is handled easily, so that traffic can make the smooth. And the third one, that is in some cases suddenly system is failed, so in that situations it is prepared to handle the situations. In the certain situations your system is going to fail, then be prepared to handle that all. So let us see here, in these directions, to balance the workload we need at least two or several cloud servers which are identical both in configurations and data. Aruba is also a load balancer that permits us to configure our load balancers and its connector directly from control panel with just a few clicks, easily and quickly. Basically configured our load balancer for the main protocol, that is HTTP, HTTPS and TCP, and handpicked one of the default balancing algorithm like least connections and source. Also balancers from side to side simple graph which indicate the workload of each load balancer. So you can also basically configure the load balancer for the main protocol. You know, friend, the main protocols are here, that is the HTTP, HTTPS and TCP, and handpicked one of the default load balancing algorithm, that is like the least connection and also the source. So you can balance the workload as per your requirement. So you can use more than 2 servers to balance the load. Now this way you can prevent overload simply by increasing the number of balanced cloud server. So sometimes you have a heavy load and your existing server is not able to process the data. In that case, you can add more server so that your load can be distributed. In this way you can solve a problem. Suppose you have a 50 jobs and you have only the 10 server. So 50 job cannot be processed in a limited amount of time by the 10 server. Then you can increase the number of server and you can distribute the load among the various server. Then you can perform the computation in very easy way with the high performance. So let us see in this diagram, client 1, client 2, client 3 here. This is your client 1, client 2, client 3 and client 4, and that connected with the load balancer. And you have here the cloud server 1, cloud server 2, cloud server 3 and cloud server 4, and that all clients are interact with each of these all server. If client 1 want to interact request, it will be sent to anywhere whenever a particular server is free. Then client second can also interact with any of the following server as per the availability of the server, and third also can request any one of the following these server and third one. But the responsibility of this load balancer can send the request of a particular client to a particular server. In this way load are distributed among the various server. So let us see here what is the objective of load balancer. Load balancer is a physical device and having the objective, the first objective of load balancing, that is maintain system performance. Second objective of load balancing, that is improve system performance, and third one, that protect against system failure. These all are the objective of load balancer. Let us see here a cloud provider like Amazon Web Services, Microsoft, Azure and Google that offer cloud load balancing to enable us for simple distributions of workload among servers. So see one example, AWS offers elastic load balancing, that is known as ELB technology, to distribute traffic among EC2 instances. So most of the AWS prepared applications have ELB installed as key architectural component. Similarly, Azure Traffic Manager allocates its cloud server traffic across multiple data center. So if you have a multiple data center, then the Azure Traffic Manager that allocate its cloud services so that it can make the traffic smooth, and AWS that offer an ELB technology. So ELB technology is used to distribute the traffic among the EC2 instances. So most of the AWS providers, most of the AWS Powers application have ELB installed as a key architectural component. Now let us see here load balancing solutions. So you can say the classifications of load balancing solutions. So friend, you can understand the various type of load balancing solutions. You can understand load balancing solution with the help of this diagram. So the following diagram shows the classifications of load balancing. The first one, that is known as the static or policy driven. Second classifications for load balancing solution, that is the random strategy based. And the third load balancing solutions, that is the dynamic or feedback driven. And the next, that is the centralized, and next that is the decentralized, and last one, that is the load balancing solution, that is known as the clustering based solutions. So these all are the classifications of load balancing solutions. So friend, you want to solve your problem related to load balancing, so you can use any of the following, like a static policy driven, random strategy, dynamic feedback driven, centralized, decentralized, clustering based. So these all are the classifications of load balancing solution. According to your requirement, you can use any of the following. So now see here, when load balancing is required, the question is here whether load balancing is required or not, but in which situations a load balancing is required. Let us see here. In each high traffic is the only needed? No. Is there is one kind of load balancer? No. But do ideally all need a load balancer? Yes. And do I need a plan for load balancing? That you can say also yes. So let us see here an excellent demonstrations of load balancing by Rock Space Cloud. So in this diagram, let us see here, this is the World Wide Web. So in a World Wide Web, all the informations and data and the users are here, and there these all users can make the request, and that request will be transferred to the cloud load balancers, and that load balancer route to the cloud server. So here the cloud server 1, cloud server 2, cloud server 3, cloud server 4, and so on. Here may be n cloud server, and between the users and the cloud server, a cloud load balancers is used, and the responsibility of load balancer to balance the request taken from user and allocated to the particular server. So this is the known as the load balancing by the Rock Space Cloud. And when you think that when load balancing is required, so let us see here how does load balancing work. Now see the mechanism that how load balancing actually work here. So load here refer to not only the website traffic, however conjointly include CPU load, network load, memory, capability of every server. And see here a load balancing technique that makes certain that every system with the network has same quantity of labor at any instant of your time. This implies neither any of them is overly overloaded or underutilization. So you have to see here which of the following server is underutilizations and which of the following server are underutilizations. So the server that is underutilization, then the next coming job should be given to the underutilization server, and the heavy servers data may be transferred to the lightly loaded server. So in this way this load balancer work here. Now see here, the load balancer allocate data relying upon however busy every server or node is. Within the absence of load balancer, the client should wait, whereas his method get processed, which could be too exhausting and discouraging for him. In the case of absence of load balancer is not available, so client are waiting for its data get processed, then it will take more time, because users have to manage itself, because load balancer is not available. If load balancer is available, then can manage and transfer the data from one server to another server to get the processed data easily. So here there will be problems of exhausting and discouraging for the him. So several information like job waiting in queue, CPU unit processing rate, job arrival rate, etc., area, unit swapped between the method throughout the load leveling process. So if in the case of failure within the right applications of load balancers will result in serious consequences, information obtaining loss being one among them. So let us see and understand, friend, with the help of this diagram. Here is the user, this is the internet, and you can place the load balancer here, and this load balancer can allocate the particular server for the users, and then finally database, in a database data are stored. So let us see here in the diagram, load balancer interact with the that is the web server group 1, the second one web server group 2, and third one web server group 3. There is a forum. So in this way the user can interact, and user requests can be distributed among the various server, various node. And if a particular node is heavily loaded and some node are lightly loaded, so the load from the heavily loaded server data are transferred to lightly loaded server. In this way user can get their request response easily, and process the request of the client will process in easily way, and this system can increase the performance so that any user can perform their task easily due to the help of load balancer. So friend, after a short break we will come back. Thank you, ma'am.
With this note, thank you, sir. Thank you so very much for giving us this session on load balancing in cloud computing. Friends, there is a lot more for you, and if you are interested in knowing more, so you are requested to be with us as we are back after a short break, and we promise to give you more. Thank you. Hello friends, welcome back to this session. Friends, as you know that today we are talking on load balancing in cloud computing, and for the discussion on the topic we have with us in our studios Dr. Mansaf Alam. Dr. Mansaf Alam is Associate Professor in Department of Computer Science, Jamia Millia Islamia. Dear friends, Dr. Alam has immense experience, and we always try to get in-depth knowledge through him. If you wish to ask questions from Dr. Mansaf Alam, then you can contact us through our toll-free number. Our number is 1-800-110-430. I repeat, our number is 1-800-110-430. You just need to talk to us in the last 10 minutes, and you're requested to ask questions relevant to the topic only. Now, I would like to welcome our guest, Dr. Mansaf Alam, once again. Hello, sir.
Thank you, ma'am. Welcome back, friend. Myself, Dr. Mansaf Alam, Associate Professor, Department of Computer Science, Jamia Millia line. Friend, before the break I was discussing about the load balancer managing the various server in the case of failure within the right applications of load balancers that will result in serious consequences. So, information obtaining lost being one among them. So, let us see here cloud load balancing advantages. What are the various advantages of using the cloud load balancing? So, friend, the first advantage being using the cloud load balancing, that is the high performance applications. So, high performance applications means the you can perform the high application in the high performance, and second one, that is the increased scalability is the second advantage of cloud load balancing, and the third advantage of cloud load balancing, that is the ability to handle sudden traffic spikes, and the fourth advantage of cloud load balancing, that is business continuity with the complex flexibility. So, friend, let us see in details about the high performance applications. So, what do you mean by the high performance or high performing applications? So, cloud load balancing techniques that dissimilar their traditional on premises corresponding item are less expensive and simple to implement. Enterprises can make their client applications work faster and deliver better performance, that too at potential lower cost. So, high performing means the work, the implementations of the work that can be done in the faster way, means your data can be processed in the faster way and that can deliver the better performance if the job will be completed in limited amount of time and that deliver the better performance. So, to increase the performance of the applications is the objective of cloud load balancing. So, this is the very important that you can increase the performance and give the deliver better performance and the client application work fast, and it is also corresponding that it is a less expensive and it is also simple to implement. So, this is the first objective of cloud load balancing. Now, let us see here the second advantages of cloud load balancing, that is known as the increased scalability. So, what do you mean by increased scalability? The system is scalable. So, cloud load balancing take help of cloud's scalability and agility to maintain website traffic by using efficient load balancers. So, you can use the various efficient load balancers that we can easily match up the improved user traffic and allocate it among many server or network devices. So, it is especially important for e-commerce websites who deals with thousands of website visitors every second. So, if you have a 10 server and suddenly more traffic are coming, then you have to use more other server to handle the maximum traffic. So, this is basically used in the commercial e-commerce website that generally deal with the thousands of website visitors in every second. So, there the scalability also maintain the website traffic and also use the efficient load balancer that easily match up the improved use traffic and allocate. So, now let us see with the help of this diagram here client 1, client 2 and client 3 are connected with the cloud and here this is the balancer, load balancer, and 3 servers, server A, server B, and the server C. This is the existing infrastructure on which the client can get the response from the server, and server can process the request of the client 1, client 2, client 3, and load balancer can distribute the load among these. So if the client here during sales or other advertising offer, they need such effective load balancer to distribute the workload, but these all servers are heavily loaded. This is heavily loaded, this is heavily loaded, and this server is heavily loaded, and a high load with the all server, and there is more and more requests with the client, and they want to get services from the server, but these all server are busy and all are heavily loaded. Then you can also add more server to the existing one to solve the problem like this. Let us see first. You can use the one server. This is first server is added to the existing one. So you can connect with the load balancer. Then the some workload that having with the server A, server B, that will be transferred to the server 1. Then you can also use the server 2, that is the additional server used here to transfer some job to here, that will be processed. And the next, that is the server, next a third server, and that is also connected with load balances. So the load with the existing server, that load will be distributed among the server 1, server 2, server 3, that is additionally added to the network, to the system to process the data in very easy way, in the fast way. So this is known as the add-on server added to the existing to solve the problem. So this added that known as the scalable. So there is a facility of scalability in this. So as per requirement, you can add more server to solve your problems. Now the third objective of load balancing technique, that is the ability to handle sudden traffic spikes. So generally running university site can completely go down during any result declaration. So this is because too many requests can arrive at the same time. If they are using cloud load balancer, they do not need to worry about such traffic surge. No matter how large the request is, it can be cleverly distributed among the diverse server for generating maximum result in response time. So let us see here, a university is going to declare their result. So as soon as university declare their result on the website, so many users, so many clients can interact with the website. In that situations, the server may be fail due to the heavy load on the server. So most of the students are not able to see the result because the server is failed, because at the same time huge people are accessing the website of a university, because everyone interested to see their result. So if 1 lakh students are enrolled in the university and the result is uploaded at the same time, so 1 lakh student can hit at a time, then that situation the server may be down. So university people will be in very tension how to solve these problems, and students are not able to get the result, students are not able to see the result. So to solve such type of problem, a load balancing technique, load balancer is used there. If there is a heavy traffic, so the load will be transferred to the other server. In this way, load will be distributed among the various server. So many people can try to hit, then they can try hit the network and the site they can access. So huge people can access the site. There is no problem because the load will be distributed among the various server. So in this way university can solve their problem by introducing the load balancer. So this is the third objective of using the load balancing to solve the problem related to the result declaration, and so many users client can access it, then load distributor will distribute the load among. So your website will not be down and server will not be down. So you can get the result on a time, and all the students can see the result on the time, and there is no problem no matter how large the request is. So it can be clearly distributed among the diverse server for generating maximum result in response time. And the fourth objective of load balancing, that is known as the business continuity with complete flexibility. So the elementary objective of using a load balancer is to save or protect a website from sudden outage when the workload is distributed among various server or network unit. Even if one node fails, the burden can be shifted another active node. Therefore, with increased redundancy, scalability and other features, load balancing easily handle website or application traffic. So let us see friend here, when the workload is distributed among various server or a network unit, even if one node fail suddenly, then the that can be shifted to the another active node. So if there are a 4 node here and the load are distributed among these all 4 nodes, and suddenly one node get fail. So don't worry, the load of node 1 that is going to be failed, that will be routed to the another active node. So in this way you can solve your problem. So that shows this will be continuous, and the business will be continuous, and there is a continuity in the business with the complex flexibility. So there is a complete flexibility in load balancing. In a load balancing can help the users to transfer their data from one node to another node in the case of failure of the node. So in this way it is great helpful for the system to distribute the load among the server. So this is the fourth objective of load balancing, that is business continuity with the complete flexibility. Now let us see here importance of load balancing in the cloud computing. So information technology industry is one of the fastest growing industries across the globe. Big thanks to cloud computing, due to which a large quantity big thanks to cloud computing, due to which a large quantity of data is generated and interchanged over the network for better capitalizations of companies significant investment. So now see here, the cloud has allowed enterprises to take the benefit of computing resources which are usually shared in virtualized environment. Most of the company have now switched over to cloud based services. Now here the cloud computing brings up the concept of load balancing, which is important to know, known by all those who are using cloud computing or about to turn into it. So friend, let us see here various types of load balancing algorithms, and we have seen the importance of load balancing, how load balancing work, what are the importance of load balancing, and load balancing play important role for distributing the load among the server. Now let us see here what are the various types of load balancing algorithm. So first one that is known as the static algorithm, second one that is known as the dynamic algorithm, third one known as the sender initiative algorithm, fourth one receiver initiated algorithm, next one symmetric algorithm, and centralized approach, and the last one decentralized approach. So these all are the various types of load balancing algorithm. Let us see first one, the static algorithm. यानी कि just you can say here कि before starting the execution, the prior informations are required, and once the job is initiated, then the changes will not be permitted. So the executions of these algorithms do not take into account the current state of the systems. Hence these algorithms don't depend on the current state which the system is in. A static algorithm have prior knowledge related to system resources and detail of the all tasks. So before going to start the executions, all the information related to the job should be there to start the execution. Once you have started the executions, there is no changes. So let us see here, cloud require prior information of the following. What are the information are required in before and prior to executions of the program? The first one that require the server capacity, second one power of processing, third one memory network, next one performance, next one user requirements, and then the user requirements will not be changed once it started execution. So if execution is started, so there is no change, and these all are required before starting the executions. So let us see here, there is no load change in once it is started. Once the execution is started, so there is no changes in the load. If you want to change in the load after starting the executions, so that is not possible in the case of a static algorithm. So before starting, you can manage, you can assign what should be changes, what load should be given, that all should be decided before starting the execution. Once the execution is started, so there is no change in the load. And here the simulation is easy. In the case of a static algorithm, you can say the simulation is easy but not suitable for heterogeneous cloud. So in the case of heterogeneous cloud, I suggest a static algorithm is not good, but the simulation purpose it is good. So for the simulation purpose, you can use the static algorithm, but in the case of heterogeneous cloud, you can't use the static algorithm, and it requires a prior information of the system and not depend on the current state of the system. So friend, these all about the static algorithm. So now let us see the second type of algorithm, that is known as the dynamic algorithm. So dynamic algorithm take the current system state into account while taking decision, unlike a static algorithm which do not do so. These algorithms don't require any prior knowledge of the system. So state workload is distributed among the processors during the executions of the algorithm. Unlike the static algorithm, dynamic algorithm buffer the process in the queue on the main node and allocate dynamically upon request from remote node. As default, dynamic load balancing algorithm can provide a significant improvement in the performance over the static algorithm. So dynamic algorithm, that is very good algorithm, and it allocate the load when the when execution started. So in the case of dynamic algorithm, jobs are assigned at the runtime. So in the case of dynamic algorithm, jobs are generally assigned at the runtime. Also jobs are assigned at the runtime that depends on the situation that the load is transferred from his high load server to low load server, and the communications overhead occur and become more when number processor increase. So no decision is taken until the process get started. So this all about the dynamic algorithm. Now let us see here the next type of algorithm, that is known as the sender initiative algorithm. So in this case there is two node. First node is known as the sender, and second node that is known as the receiver. So sender initiative algorithm means the sender node can get the startup, get the initiations to transfer the data. So receiver is not going to take the initiative first. The first sender is taking initiative to transfer the data, so they can start request for the lightly loaded server. I want to transfer the data. So sender initiated algorithm of load balancing is initiated by the sender here, and the sender transmit the request message until it get receiver that can accept the workload. Let us see here, there is two node. The first node is low load, or you can say it is a lightly loaded node or server, and this is the heavily loaded server. Now this is your sender node and this is your receiver node. So first the heavily loaded sender node can request. So here they transfer the data to the low loaded, and when this low loaded and lightly loaded server agree to accept the data, so it will send the acceptance to heavily loaded node, and then the heavily loaded node can transfer the data. So friend, you know there is a two node, one node that having the high load, that is the heavily loaded, and second is the lightly loaded. So the initiative, who will take the initiative to transfer the data, the heavily loaded node can take the initiative to transfer the data. So first heavily loaded node send the request to low loaded node or a lightly loaded node to transfer the data. If they accept it, then send the message, yes, you can send, then directly heavily loaded node can transfer the data to the lightly loaded node. So that scheme, that algorithm is known as the sender initiated algorithm. So in this sender initiated algorithm, let us see here, heavily loaded server, that is known as the sender, that start actively. So activity that will be started by the heavily loaded server, and a job is sent to the low loaded server, that is known as the receiver. That is the best of the following condition. There are certain conditions, based on that condition sender job is sent. The first policy is known as the policy for the transfer. So a server is identified as a sender if a new job originated at the server that makes queue length exceed a T threshold. And another policy, that is policy for the selection. The new job coming are considered only for the transfer. So this is the policy for the transfer, and policy for the selection is considered when a job is transferred from sent to the low loaded server. And the third condition, policy for the locations. So random, no prior information is exchanged, it is randomly locations policy. And threshold, that is known as that is T, to determine receiver that polling server is selected on random basis. So, shortest to find the queue, a group of server are polled. And next condition, that is the policy for the information. So, it is a demand driven type, and last is that a policy, that is the stability. So, if a system in stability at high server, then location policy is adopted. So, friend, that all about the sender initiated algorithm, and next algorithm, that is known as the receiver initiated algorithm. In the case of receiver initiated algorithm, receiver can take the initiative. Who is the receiver and who is the sender? A receiver, that is lightly loaded, and the sender, that is the heavily loaded. But in this case, the initiative is taken by low load or lightly load node. So, receiver initiated algorithm of load balancing is initiated by the receiver. Here the receiver transmit the request message till it find a sender that can accept the workload. So, here that is the load take the initiative, and then heavily load transfer the data. Now, so lightly low loaded server receiver that take initiative to get job from heavily loaded server, that is sender, with the following condition. The first one, the policy for the transfer. When a job depart, then it started. Second policy of policy, that is for selection. How can you select it? The new job coming are considered only for the transfer. And the third policy for locations, on the random basis, a server is selected to poll to determine if transferring a job from it would place its length below the level of threshold T. If it is not, then poll the transfer of a job. So, this is the policy for information also will be considered in the receiver initiated algorithm, that is it is demand driven type. And the stability, in the case of lightly loaded, it is a spare CPU cycle, but do not cause the system. So, in instability, in the case of heavily loaded system, it is expensive because most transfer are preempted. So, friend, next that algorithm is known as the symmetric algorithm, and you can say symmetric algorithm is the combinations of sender initiated algorithm plus receiver initiated algorithm that all combine together to give the birth of symmetric algorithm. And the second last algorithm, that is the centralized approach algorithm. So, the you can say also the centralized approach. So, the jobs and workload is distributed from a centralized locations to different process. There is a master slave relations between the centralized locations and process centralized approach. So, here this is the centralized, that is the masters, and the process at A, B, C and D, that is the slave. So, this work on the master slave concept. So, here centralized approach collect information about server and take decision on the assignment. Then efficient decision is taken by the centralized approach. Master processor maintain pool of network like queue and heap, etc. Slave processor perform task and then request for the another job. So, it divide it is based on, it use the divide and conquer algorithm to distribute for pool of work. So, advantages of centralized over the decentralized over centralized approach, queue and task. So, multiple processes are used to manage queue, mean low effective dynamic task and low continuations and the continuous delay with the access to queue of the task. So, disadvantages of the centralized queue and the task, it is difficult to determine parallel computations terminations, and second one, it require a terminations detections algorithm, and it require a termination detections. So, friend, I hope you understand this lecture, and the next lecture I will teach more things. Thank you, ma'am.
With this, thank you, sir. Thank you so very much for giving us this is a session on load balancing in cloud computing. Dear friends, if you have any query or feedback, then do write to us at info.cec@nic.in. We are going to meet again very soon. Till then, take care. Goodbye. Thank you, sir. Thank you once again.